Hey, this is John with Two Moose Home Inspections. Welcome to the February 2022 in-service training. If this is your first time joining us for an in-service training, I recommend setting that speed to 2x so that way we can get through it a lot faster. Very first thing, let's jump into it. We have some new beanies for the company. So basically, it's the middle of winter, and with it being the middle of winter, you definitely want to wear some hats so that way you can cover up your ears. And we have it with the Two Moose logo on it. So some new stuff. Everybody already has their Patagonia jackets and shells and all that kind of stuff. Their MSR snowshoes. They got everything they need, right? But the one thing we were lacking was a beanie. So now everybody's got beanies. We are good to go. The next thing that we have on there is virtual tours. So we've picked the virtual tour software. We are going through it. We are setting all the templates the way that we want the templates to be set. We are basically on the back end getting things working the way that we want to start to automate a process. And then I will be making all of the basically training documents for our guys to make sure that we are consistent every single time, regardless of who does the virtual tour. So setting up some new procedures, new policies. So that is in the works. So hopefully sooner rather than later, we will have that available. But we are just working out a couple of kinks. Additionally, floor plans, we are working out the kinks with that as well. As far as, not that there's necessarily, well, there's a few things that I would like to have different with the software, but the software is working well enough. And so then basically it's just going to be a policy procedure about when do we make exact measurements with the laser versus when do we make approximated measurements on like how many of the walls. So for instance, like if we're in a square box, we really only need to have 2 of the walls to have the exact measurement. And if the cubby is off by half an inch to the left or to the right, is that something that we're willing to accept? And so that is something that we're kind of working right now to make sure that we have a good balance of precision versus, whatever. Because on a 500 square foot condo, it doesn't matter. Like we will do everything as precise as possible. But whenever you're talking about a 6,000, 12,000 square foot house, and if you think that's unrealistic, what was it, 2 months ago, a month and a half ago, we had a 12,000 square foot house. That took forever. And so anytime that we have larger houses like that, we want the actual square footage to be as accurate as possible. We want the rooms to be as accurate as possible. But maybe whenever we're talking about is a little alcove here off by half an inch or not, maybe that's something that we're willing to accept. And so we're just trying to figure out what that looks like, if that's something we can do, and go from there. So talking about things that we're willing to accept or not, let's jump into the first topic here. So the first part of a report that we're talking about is actually from the EPA. It is the Soil Gas Mitigation Standards for Existing Homes with 2020 revisions, and it outlines everything that you need to know whenever you're installing a radon system. And so radon mitigation system. And so this has everything here listed out, exactly everything that you need to know. And these are just a couple of excerpts because we had a customer, whenever we first did the inspection, we said, hey, we don't like where this radon system is. It was actually inside of the garage. So it is sucking up, so area of low pressure, and then at the fan, it then creates high pressure as it pushes out the gas, the radon, and it pushes all of that air out. Now, if there was an issue with the housing of the fan, or if there was an issue with the pipe, then that radon could come into that garage space. Now, that garage is not a living space. However, could you see yourself being in the garage working on the workbench for several hours? Yes. Working on your car for several hours? Yes. Working on any project, or let's say that you have kids and it's the middle of winter and they want to ride their scooter. Well, then the garage is a perfect place for that to happen. I have seen houses that they have, golf set up inside of their garage where they have so many activities in their garage because in the middle of winter, that may be a great opportunity to have a heated, warm area to do so. So what that means is that if we have any kind of leak that has radon in it, then we have radioactive gas leaking into this space that we could then have our small children or ourselves in, which is going to increase our risk for lung cancer. So what we have here are guidelines that are set out by the EPA. Now, I know this says 2020 revision. The thing is, this is a 2020 revision. However, these standards have been standard for a very, very long time. The revisions that we're talking about have nothing to do with what we're talking about right here. They just happen to have a revised copy. So what happened was these people came and installed the radon system on the exterior of the home, but they took the exhaust port, and that exhaust port, what they did with it was they didn't get it to go past the roof line. It's going right into a soffit. It's really, really close to a window. I don't even know if it's the right height off the ground because I didn't have a measuring, but I just looked at it and I was like, look at all these other issues that we have going on. There were no permits pulled. There was just a whole bunch of, issue. And I feel really bad because the couple that had it installed, you hire somebody to do a job and you expect them to do a good job, and that should be the end of it. And that is rarely ever the case. I have one other funny story. We had maybe it's not a funny story. we're going into the rabbit hole. I get it. Talking about companies that aren't great, there is a company that we still recommend. We still recommend this company to take care of chimneys and to take care of fireplaces because they are the best in the area. However, whenever we talk about companies and whenever we talk about somebody and their there being a conflict of interest. The conflict of interest that they have is that if they say something is wrong, then what happens is that they can then charge to have some work done. Now, as an inspector, if I find stuff wrong with your house, I don't care. If I don't find stuff wrong with your house, that's probably better for me. But the thing is, I enjoy finding things wrong. And so for me, if you pay me more money or less money, I'm going to find things. And so there's really no incentive for me to lie. Whereas whenever we have other companies, there is an incentive for them to lie about the work being performed, whether or not it's a serious issue or not a serious issue, because they either have money on the line, where if they installed it incorrectly, they might say, oh, no, it's fine. Don't worry about it. It's for this guy. He doesn't know what he's talking about. These documents here that the EPA made, they don't know what they're talking about. It's just, don't worry about it. Anyway, so what we had happen was, we looked at this fireplace. Fireplace was immaculate. Everything was good. I mean, it was old, but it was good. And we have our constant detectors that are on that basically tell us whether or not there are high levels of carbon monoxide. And there are standards for testing a fireplace to make sure carbon monoxide standards, whatever. Anyway, we had this customer, super smart lady, awesome. And she's like, give me all the information. So we gave her all the information. And basically what had happened was this company that we still recommend because they're still the best, but it's just like, because we've gotten this with plumbers, we've gotten this with HVAC, and we've also now gotten it with fire installation companies, fireplace installation companies, where they said, oh, well, you had high levels of carbon monoxide. And then she's like, but when? And they're like, as soon as we turned it on. And she's like, okay. And then what was the reading? Well, 30 seconds later, it was lower. And it's like, okay. And so then whenever you consider that the standard is to let the fireplace run for an extended period of time, normally about 5 minutes or so before you run your first carbon monoxide testing, then that just means that, okay, there was a natural induction or induced draft, basically, that as that air heated up inside, then it started to create the draft, and then it took all the carbon monoxide out. And so nothing ever passed beyond the standard level of carbon monoxide that was actually like appropriate. Everything was perfectly safe. OSHA would be happy. You could work an 8-hour workday with that much constantly doing its thing, but it was only there for the first few seconds. And then after that, it was working perfectly fine. But the thing is that people use fear and people use information skewed to basically speak their narrative. And so same thing here. We have EPA standards, but this company is saying, no, there's nothing wrong. We installed it perfectly fine. We have standards for how to test a fireplace. And this fireplace company is saying, oh, you need a whole new fireplace insert because of this carbon monoxide level. Well, what was the level? Well, it was like 20 parts per million. Okay, that's fine. What was it later? Well, 10 seconds later, it was less than 10. Okay. And then what was it like after a minute? Oh, there was nothing. Okay, that's expected. That is completely expected. All right, we're out of the rabbit hole. My apologies. We're moving on to the next thing. Sorry, but sometimes there are companies that either do it wrong or there are companies that lie to make more money. And man, does that happen a lot. It happens so much in this industry and it just kills me. Absolutely kills me. All right, so very first thing, Flagstone repairs recommended. And so basically what happens here is that this natural, rustic, rough looking flagstone looks amazing. It looks so good. But the problem is that as we have water melting, then the water expands and contracts. And then we have this freeze-thaw cycle that will pop the rock off. Now to fix this, it's pretty easy to do. You just put on some more mortar. Then you put a wire. So you probably just screw in a wire. Screw in a screw, tie some wire to it, put on a whole bunch of mortar, and then tie the rock using that wire. And then once that sets, then you're good to go. Snip the wire, you're done. Not a big deal, but it's one of those things that you definitely do want to fix. Then if you read the blog post that we had about all the different like covers that go to lamps and lights, this is your opportunity now that it's missing to get a whole new design. Now, can you find the exact same thing? No, there's no way that you're going to find the exact same light cover. It's just impossible. You will never find the exact same light cover. But this is now an opportunity for you to replace it with whatever you want. So the problem is, and the reason that we put this into inspection reports is, does it matter? No, not really. However, it does cost you money, or it may never look the way that you want it to look. So GFCI protection, not installed. I think we've talked about this a million times. I think this one is behind a laundry machine. Now, why is it that we need to have GFCI protection behind a laundry machine? Because your washer is interacting with water. If there were a leak, if water were to come onto the floor and you stepped on that water and there was no GFCI there and we had some kind of electrical fault as well, stepping on that water might be enough to kill you. And so if there's a GFCI installed, then we are golden. There is nothing you need to worry about, and you are going to be, well, maybe not nothing you need to worry about, but fix the leak, fix the electrical issue, and then tell all your friends that you were shocked, because you can't tell them that you've been electrocuted because you'd be dead. But with this, at least, hopefully this is what it would take to save your life. Now, whenever we talk about vents, a lot of times we need to make sure that that vent, that dryer duct is completely clean. The reason it has to be clean is because if not, then that dryer lint is going to get stuck in there, and then that high heat might catch that on fire. And if it does catch it on fire, then you're going to have a really, really bad time. So two things were wrong with this. One is we didn't have a dryer vent cover. So there was no cover to prevent squirrels, chipmunks, or anything else from going back into the vent. And additionally, there was a whole bunch of dryer lint that was outside of the vent. And so then that just means, hey, it's probably time to do a cleaning, because you should be cleaning it once a year. When we take a look at this, some of the burners were not igniting. Now, we do our best to make sure there are two, basically there's a gas dispersion puck, if you want to consider it that. So the valve comes up that has the gas, and then there's a puck that then distributes it around, and then there's a cap that goes on that. Now, where that puck is, that's actually where the igniter is going to, jump that spark that will then ignite the gas, and then the cap is like the final, thing that helps to disperse it. If those are out of alignment, then it may not light. Now, however, we have made adjustments, modifications, movement of those things. Sometimes they get, whenever somebody cleans, they put them in the wrong place. And so we do our best to make sure things are good. In this case, we weren't able to figure it out in a quick enough amount of time. So that could mean that there was a dirty valve, a bad valve, any component could have been dirty, a million different things, maybe something preventing the spark from arcing over where it's supposed to be, bad igniter, could be a million different things. But the main thing is we just want to say, hey, it's not igniting. And that's a very common thing to have happen, but sometimes the repair can be a little bit more expensive than you want. So this one here was interesting, is that we have an active leak. And so one of the things that you'll see in this is that it says that we had 32 to 40% moisture. Now, what does that mean? It means nothing. Don't worry about that number. The number is not of importance. Basically, what we care about is there more moisture here and less moisture here? If that's the case, this section is wet. If the number is, 100 and the number is 100, well, in that case, if it's 100, it's wet. But basically what I'm getting at is that if it's the same and it's the same, and we can verify, that it's always the same, then the number itself isn't what matters. What matters is that there's a difference. There's a wet spot and there's a dry spot. Now on this, with it being 32 to 40%, that is pretty wet. And the way that these moisture meters are actually calibrated is to go into a piece of wood, not drywall. And so the numbers that we see whenever we say 32 to 40% saturation, that is not always accurate whenever it comes to drywall, because we're talking about the conductivity of electricity between those 2 points whenever we stick the prong in. The main thing that we want to say is not that the numbers are of importance, but that there is a difference in moisture, and that this area is wet, this area is dry, therefore we have a leak. And lo and behold, we actually did have a leak, and it was coming across the wall. So one of the things, whenever you take a look at our frozen pipe series, one of the things that you'll notice is that we made a comment that said that it could hit the drywall, and even though the leak is right here, you may not see the leak until it's all the way out here. And the reason you don't see that leak is because it's not going to saturate and drip through the drywall necessarily. It's going to be on the surface of the drywall, and then whenever it gets to a seam or a crack, it is going to then fall through the crack, and then that's whenever you're going to see the paint bubbling up and all the issues that you might have in water dripping. And so even though we're seeing it here, the leak might be all the way back here. And so whenever we see something like this, I cannot definitively state that the leak is occurring because we have an issue with an ice dam, because we have an issue with a leaky pipe. I don't know that, because that issue could be 8 feet, 12 feet away from where we're actually detecting the water. So all we can really do right here is say, hey, somebody needs to do some serious digging to figure out where this water is coming from. So that's why it's red, because we have no idea what the extent of this is going to be. So reverse polarity. So we've talked about reverse polarity, and basically what that means is that it's alternating current. So yes, you're correct that it doesn't really matter if it's reverse polarity, but there are certain devices that have safeties or other things like that, like a GFCI, or even are just built or designed in a certain way that it expects the electricity to go through it one way and then out the other. And sometimes that reverse polarity can result in electrical shock hazards, and it can also cause whatever appliance or item or electronic that you're installing or plugging into that outlet, it can cause that to fail. And if that fails, then obviously that would be a bad thing. So when we come into, oh, and fixing it, it's not really that big of a deal. You basically just take the wires and you just flip flop them and you're good to go. Now, sometimes, we'll go back to this here. Sometimes what can happen is that if I had, 8 outlets, 1, 2, 3, 4, 5, 6, 7, 8, I might notice the issue on the 8th one, but the issue actually started on the 1st. And if I would have checked the 8, 7, 6, 5, 4, 3, 2, 1, I would have noticed that they are all reverse polarity. And all I have to do is switch this one right here, boom, switch that, and now all of them are fixed. So somewhere along the line, I could have gotten the wires mixed up. And if that was the case, I just need to replace them or flip-flop them, and then we're good to go. So it's really just understanding how the electricity flows through the wires or the conductors. So the next thing is water damage to the base of the cabinet. When we talk about water damage to the base of the cabinet, it's kind of like a thing where, one, you don't know when the water damage occurred. It could have occurred in the 1970s, and obviously the cabinet is still damaged because nobody's going to take the time to replace that, because why would they? You don't look at it. It's dry. It's no big deal. Who cares if there's cosmetic damage? Or it could have just happened last week and somebody tried to wipe it up, and this is now the issue that we have. So we like to say that there is an issue. In this particular case, there was a later statement that then showed that it was actually actively leaking as well. And that, of course, then is a problem. But that was a separate thing. We're just saying that right here, you might have to replace the cabinetry because, or the vanity, I should say, because it was damaged. So when we take a look at water pipes here for the hydronic heating system, we have a whole series about hydronic heating systems, blog post, all of it. And this has polybutylene pipe. Now, polybutylene pipe, poly-B, no good. Since 1995, it has been banned, outlawed, whatever. So this particular house falls into that date range. This right here says PB, 2110, whatever it says right there on the pipe. It is polybutylene. And the problem is that with polybutylene, one is that it was oxygen permeable, which means that oxygen can go in, and then that means that you are going to get oxidation or rust forming inside of your circulation pumps, your valves, or in your boiler. And so therefore, that's bad. But what you can do is that you can just put in a stainless steel heat exchanger, and that will isolate the poly-B that has all the oxygen coming into the system. And then you can have a part of the system that is on the other side of the heat exchanger, where the boiler is, that has no oxygen in that system, where basically that is an oxygen depleted closed loop part of the system, and therefore your iron boiler is not going to rust away. So that is something that can be done. It's relatively inexpensive compared to what the other alternatives are. But the other thing to keep in mind is that polybutylene, whenever it is heated, the plastics break down a little bit and will leak. So that's bad. That's why it's been banned or outlawed since 1995 or whatever. So in this particular case, there are two ways to look at this. One is, okay, great. What I can do is I can install a stainless steel heat exchanger, and now my boiler is safe. Okay, but now my other question is, what is the risk of having water leak somewhere in your house? Is this polybutylene newer? Is it older? Are there fittings that are hidden somewhere? What are our risks? And so in general, this is red, and I would definitely recommend that you talk to an HVAC specialist about what the options are, A, to take care of the oxygen permeability issue, and then B, to take care of the well-known issue of polybutylene pipes becoming brittle, cracking, and just general fatigue of the pipe that causes a rupture or failure. So, not the best, not the worst, but just not the best. So if we talk about shower walls here, so this shower had a lot of issues, but you can already see in these pictures that we're having a problem. Now, whenever you push on the tiles, I'm going to give you a little trade secret here. Whenever you push on the walls of a shower, it should not feel wet and spongy. It should feel very solid and dry. And this was not the case. So what the real underlying issue here is that we have somehow gotten water that can get back behind there, whether that was a pinhole leak that is just slowly spraying water onto the walls, whether it is that we didn't properly caulk or seal around the bathtub, which is also very, very possible. There's a lot of things that you have to do in the background. Could be they didn't use any of the materials that they were supposed to use, which is probably the case. And then what this means is that inside, we might have to remove studs because there could be mold or other issues inside the wall. And so not only would we, if let's say I am here and this is the bathroom, side right here. So I'm in the bathtub. Here's the wall. Here's the stud. Here's the other side of the wall. This whole cavity between these two walls can have mold all in it. And so that means that not only am I replacing the drywall here at the bathtub side, I might have to replace these studs. And then I might also have to replace the drywall. Let's say there's a bedroom on the other side. I might have to replace that drywall as well to properly take care of the health hazard and get it taken care of. So whenever you see stuff like that, not the greatest. Now, this particular house, a lot of these issues right here are actually from that particular house, and the house just wasn't in great condition. Now, whenever you see a house that isn't in great condition, is that a deal breaker? Heck no. Every house is built by a person, which means that a person can fix a house. And so whenever we see a lot of issues, yes, it's going to cost more money, but you should be able to negotiate, hey, this house is a dump, therefore you should give me dump pricing. Because then what you're going to do is you're going to come in, you're going to fix whatever, this, that, the other, boom, flip it, make a huge profit. So I think that buying a house that has a lot of issues, not really a big deal. It just depends on you and your risk aversion. If you are a handy DIY person, you're going to make a killing. If you're not a handy DIY person, you're going to invest some money and then make a killing. Either way, you're making a killing. So it's a good thing. When we take a look at this, door damage severe. So you can see there's like 3 other pictures, which means that we have a total of 6 doors that are pretty badly damaged. Here's an example of a couple of doors here that were damaged. This right here is a hollow core door, and as you can see, the door has been just damaged, broken, destroyed. Lots of things wrong with this door, barely staying held together. It's, you know, just a peach. And then you can see this door right here, just completely damaged, destroyed. All the doors in the house were. The other thing too is that they had this countertop, which you can kind of see in this picture right here. And there was damage to the countertop. Now, here's the deal. There was this one builder, and he was very, very famous, and I can't remember his name, but his style was that he would basically reuse construction materials. So if he had something like this, and there was a chip or a crack, then what he'd do is he'd go around and he'd chip and crack every one of the vanities. If there was a crack in a window, he would make multiple cracks elsewhere throughout the window to kind of give it that whole like vibe or style. Is that great? Is that what you should be doing? No. But what was really interesting is that, for instance, like pavers for a driveway. Whenever you have pavers for a driveway, if there's a little chip on the edge of that brick, then they will throw that entire brick away. So what you could do is just collect all those pavers that have a chip on the corner and make a driveway with pavers that have that chip on each and every little corner. And then what that would do is that would give you a distressed look for your pavered driveway. And now you have a pavered driveway, which is worth millions, but it was all stuff that was going to go to the landfill. So that was his style. So if you wanted to, I guess you could say, well, I did this because it's my style and it's art. Get it? So anyway, the other thing is the caulking on this bathtub was phenomenal. So, you know, if somebody says to you, hey, I would really love it if you could caulk my bathroom here, you know, just put a little bit of caulking, a bead of caulking right over here. That would be great. Perfect. Then instead of asking an adult, you just ask, you know, a 6-year-old to do it, and bam, you got it done. So, and like, I'm being a little tongue in cheek, but this house had a lot of things that were wrong with it. So, you know, just, does it matter? No, because this is so old anyway that you're more than likely just going to be ripping it out and putting in brand new whatever you want it to be. So then you can redesign the bathrooms, redesign this, redesign that, and then take this house that you're getting for a deal and then sell it for a really, really good price. So that's my recommendation on that, because is the caulking bad? Yes, but you're going to be ripping it all out anyway, so who cares? All right, next thing, guardrail missing. So anytime that you have a loft, it's fine to have a loft that doesn't have a guardrail. But whenever you are specifically like putting a ladder there and stating that it's like a play place for kids, you don't want to put kids on top of an 8-foot tall closet effectively and allow them to fall off. So, you know, if you're going to say that it is, you know, a space, a play place, you know, whatever, a lofted area where somebody could sleep at night, you don't want it to be this. You want there to be a guardrail of some sort to keep people safe. All right. Moisture intrusion, staining. So this can be condensation. This can be a bad seal. Normally, whenever you have a window, the window, you know, sets into this frame, and that frame should not be flat. The frame should just be tilted just a little bit, maybe 5-10 degrees outside of the house. So that way, if any water gets down in, it's going to go out and away from the interior of the house. So with this right here, is it that they constructed it on a flat plane and then therefore water is coming back into the house? Or is it that you have a single pane piece of glass, and because of the two differences in temperature, you have condensate forming on it, and then it's dripping down to the bottom? I'll give you a spoiler alert. It's the condensate. So whenever you look at certain things, you can, as a home inspector, kind of tell, and then you look at the system as a whole. In this particular case, there's really no fixing it. So then what would you do in this case? I would make sure that everything is sealed around the edges to make sure that condensate, whenever it drips down, doesn't go and start to rot away any wood in that window sill. And then I would just make sure I have a really good coat of polyurethane or any other kind of like clear coat, and then we're good to go. And then what will happen with that single pane piece of glass? It'll just keep dripping water every year, and that'll just be what it does. Maybe put some like plants there, and then they'll just be super happy. So this right here, water not functioning. So if you're watching our freezing pipes series for this month, this water not functioning thing, really interesting. They specifically made a statement that was like, whenever you leave, set the temperature to 55 degrees. And as soon as I saw that, I was like, no, please no. Anytime that somebody tells me to set an old house's temperature to 55 degrees, it just scares the crap out of me, because I'm like, we're going to have some freezing pipes. So anyway, the inspector gets there trying to test the water. You know, the well is turned on, the all the electrical stuff for that is turned on, all the valves are open, everything is good to go. You go into the crawl space is freezing cold, and there you go, you got freezing pipes. And so we contact the listing agent, we contact the buyer's agent, we contact all the people, we say, hey, here's the deal, this, that, the other. We inform them that if the pipes did freeze and they ruptured, what will happen is that whenever this thaws, it is then going to just be spewing water everywhere, and that obviously is a bad thing. So anyway, whenever you have a house, don't try to save a buck or two. Keep the temperature high. You have to keep the temperature high, or at least a normal, comfortable living temperature, because if not, there are parts of the house that, because you're not using the water, could freeze and obviously would then cost you a lot of money. All right, so damage, moisture, and active. All right, so we take a look at it with the thermal camera. Everything, there's no real differential of temperature, so water's not evaporating, which means it's either completely saturated or not. Then you check it with the moisture meter, and then you know your answer. And in this case, we just have some moisture, and the moisture at this Skylight is inactive. So what's happening up here? Well, what's happening is that it could be condensation. So it could just be, okay, let's just say this is near a bathroom. We take a hot shower, all that warm, moist air goes up, touches the cold window, creates condensation, and then drips down to the edges. That's a possibility. The other is that we could have a leak around the edge of that Skylight, and we might need to have a roofer come and reseal a couple things. Hopefully it is just condensation, and it is not that we have a leak with the roof. But until we can actually verify that, we really need to be mindful, and that's, again, why we bring that kind of stuff up. All right, so subfloor damage present. Yeah, the subfloor is damaged. And here's the deal, is that they use like an MDF. So they use the fiberboard, and so you can see there's plywood and there's fiberboard, like a medium density fiberboard. So what will happen is that if that fiberboard were to get wet, if that MDF were to get wet, which as you can see it has, then what will happen is it'll expand up. And whenever it does that, in this particular house, I believe that there was like tile and other things like that that had cracked and broken, and there were like all these like waves in the floor. And so because of that, it was, pretty much, in order to fix the broken tiles and the other things like that, you'd have to first scrape off all the broken tiles, scrape off all the mortar, and then you get down to the subfloor, and you're going to have a super wavy subfloor because they used MDF, and then they put a water mortar, where basically the mortar is a whole bunch of water and then some mortar. And so then whenever you put that onto an MDF, what's going to happen? That MDF is going to absorb that water, and then it's just going to expand and balloon, and all of that tile that you just laid down will crack on day 1, day 2, day 3. And just bad building practices. That's pretty much all you can say about that. So dryer vent termination interior, inadequate vent connection. So of course we don't want that dryer vent to terminate inside the house. All that hot, humid, moist air, think of all the water that you could wring out of your clothes is now being wrung into your air, which is now going to create mold and all kinds of other issues inside of your house. So that's just a bad idea. Then whenever you say that the connection going to the exterior isn't properly connected, which it wasn't connected anyway, this right here is what was going to the exterior. This here also is wildly unacceptable as far as trying to get it to the exterior. Then whenever you talk about like the number of turns and bends, and every 90-degree turn you lose 5 feet, you have like 30 feet to get out of the house whenever it comes to getting all that hot air out and away from that laundry machine. You have 30 feet of a span that you can do, and for every 90-degree turn, you're losing 5 feet. I mean, who even knows what's going on inside of this wall? But effectively, there's some work that needs to be done. All right, so baseboard heat not working. So what we can see is that this is what baseboard heat should look like whenever it's working, and this is what baseboard heat look like. And so what you can see is that we can see the thermal loss on these pictures right here. So we can see each one of those vertical studs, and then that right there is a thermal conductivity where basically because the cold air is touching the exterior wall, which is touching the stud, which is touching the interior wall, we have that thermal bridging that is pulling that heat out, which is making that a cold spot. And that's why on exterior walls, you're going to see baseboard heat. Underneath windows, you're going to see baseboard heat or heat in general. And so here we can see that there are a couple areas where there should have been heat and there was not. In the bathroom, which is the picture just a little bit further over, you can see that the wall and the floor and all those temperatures are the same. So the bathroom's heat doesn't actually matter that much because it is inside the building envelope, whereas this one right here does matter because you can see that that exterior cold is sucking away that heat from the house, and it'd be really nice if we didn't have a cold spot whenever we walk through the house. And so that's why we really want to make sure that our heaters are working the way that they're intended. You see how that heats up the entire wall, plus obviously then it creates a convection current that causes that air, cold air to go across the floor, go to the heater, rise up the wall, and then it just creates a circle, and that's how it heats the room. That's what we want to have. All right, screws instead of nails. I think that we've talked about this a few times. A nail, you can bend a nail and bend a nail and bend a nail and bend a nail and bend a nail, bend a nail, bend a nail, then it breaks. A screw, you bend a nail, it breaks. And so what happens is that with screws, whenever I put the screw in, that screw can do what's called shearing. It'll just shear. Instead of bending, break, it's just going to shear at a moment's notice. Not even at a moment's notice, instantaneously. And so whenever you use screws, unless they are structural screws, which they weren't, then if everybody's jumping on the deck for a party that they have and those screws then shear, that whole deck could collapse and there would be no warning. Whereas if you use nails, then your deck would start to sag and sag and sag and sag, and then everybody on the deck will, fall off the deck. So that at least gives you a chance to react. With screws, you don't. So now, is anybody going to go through and replace all the screws? Probably not. Do we need to replace the screws? I mean, no, but should it be nails instead of screws? Most definitely. It's just people think, okay, screws are a really good fastener, but they don't think about the metal and the way that the metal reacts to load. All right, so damaged weather stripping. Whenever you have a door that has damaged weather stripping, just fix the weather stripping. So fixing this could help save them over the course of a winter from just this one door alone, could help save them anywhere from 10 to 50 bucks over the course of just one winter. With this particular door, with how bad it was. And so if you went through and you spent 200 bucks buying all new weather stripping for everything in the house and really making every door and window seal properly, and you spent 200 bucks, you would recoup that money, if not by the end of that year, by the end of the next year. And so always just keep an eye on your weather stripping. It's going to save you a lot of money in the long run. Highly, highly recommended. All right. This one here, overheated receptacle transformer. So basically, this is for a security system, and it's taking that alternating current and it is putting it through a transformer and creating a direct current, DC. Now, the way that it does that is basically, think of it as like a transformer inside of that. And so if you think about the way that a transformer works with magnets and so on and so forth, that's how alternating current gets transferred into direct current. So anyway, something is going wrong. It is overheating. It's not doing what it's supposed to do. And because of that, not only can you see that there is a, and I wonder if I can just make this a little bit bigger. Let's see. Oh, yes. Wonderful. So not only can you see that above that, tan box, there is a streak, and that streak is because something is burning, and that is effectively a scorch mark, and that's bad. That can catch your house on fire. And additionally, it is burned around the plastic. Now, it wasn't hot to the touch. There was no issue there. So who knows whenever that was happening, and that's why it's not in like a super red type of state. All right, so tile and grout defects. Here we go, broken tile all over the place. Whenever we talk about this, does it matter? From a beauty aesthetic standpoint, yes. Now, the next standpoint that matters is that if water can get in there, then water, like we talked about with the MDF, can start to damage the subfloor and do whatever. But additionally, if that's not filled in, whenever you step on something, there's a certain amount of pounds per square inch, a certain amount of pressure that pushes that pushes down on something. And so if the edges and the corners of the tile are not well enough supported, then you could start seeing broken tiles as, you know, people are walking on that particular surface. So we just want to get that fixed. You can buy grout repair stuff. You don't have to necessarily scrape it all out, but you could if you wanted to. This is by far some of the worst lattice that we've seen. So, you know, for a 4x8 sheet, what does it cost for a 4x8 sheet? Maybe 10 bucks, 20 bucks, depending on where you buy it. If it's already pre-stained or if it's cedar or if it's pine. But anyway, does it matter? No, it's just an aesthetic thing. That's why it's blue. But I just thought it was pretty humorous that the lattice was so badly damaged around this particular deck. So then we take a look. GFCI trip inadequate, so greater than 200 milliseconds. So it has a GFCI. The GFCI tripped, but the trip was greater than 200 milliseconds. Whenever that happens, then that's obviously bad. And so that means that we need a new GFCI installed. And if we can do that, then we're golden. So next thing, leak from water valve. So anytime that there's a leak from a water valve, there's an easy way and a hard way to fix it. Hopefully in this case, all you have to do, unscrew, remove that piece of plastic, then get a valve puller, unscrew, pull out the valve, replace the O-rings, put it back in, close it up, good to go. This should be repairable, but this is an older system. And so nowadays you aren't supposed to have hot and cold as separate things, because if a child were to go in to take a bath and they turn on the water, maybe they just turn on the scalding hot water and they don't know that that could be scalding hot water because they didn't mix in a little bit of cold, and they could be scalded inside of the bathtub. So now everything goes through a mixer valve where whenever you turn on the water, there's always a little bit of cold going into it. And if it is properly installed, the hottest hot is not above a scalding temperature. And so this is, again, an older system. So the more expensive way to do this is that you would replace this with a modern valve assembly to make sure that any occupants or users of this are going to be perfectly safe. But the repair itself, you know, you're talking $2 to repair this if you know how to do it yourself. But if you don't have the tools that you need or the know-how, then a plumber is going to charge you at least 200 bucks. So something to think about. Maybe not 200 bucks, maybe 100 bucks. But realistically, I wouldn't come out to fix this for less than $200. So just a thought. All right, so polybutylene pipe. Here we are again, polybutylene pipe. Now this polybutylene pipe is not for a hydronic system. This polybutylene pipe is for a drinking water system. And what we found was that under each and every one of these cabinets, we were able to find that there was a leak. And where the leak was is actually at each one of these valves, which is basically where polybutylene is notorious, because whenever it was crimped down onto these, fittings, that's where you would see the majority of the cracks, and underneath every single sink, it was starting to leak. And so this right here is a big issue for this polybutylene right here. So next thing, safety eyes not present. It is no big deal to install the safety eyes for a garage door. Now, very rarely do people install everything that they're supposed to install for a garage door. And I don't understand it. It's really not that hard of a thing to do. You take the safety eyes, you just line them up, they're good to go. People say, I don't need safety eyes, we're fine. Okay, great. So then did you make the adjustments to make sure that it auto bounces back if it feels any resistance? Oh, you didn't know about that? Oh, so you didn't. So what's going to happen is that if this really heavy garage door comes down, it's going to crush whatever's underneath it. That could be Fido. That could be a family member. So just think about that. So the eyes, what do the eyes do? You want them to be no more than like 6 inches off the ground. And it just makes sure that if there's anything there, that it will automatically retract the garage door that is closing. And we have seen where people put the eyes together on top of, like as a bypass on top of the thing, and they took the time to bypass the system instead of just installing the system. It's really not a big deal to install. It should just be done every time. But anyway, please keep families safe. That's all I got to say about that. All right, this one here, real gross, and this is our last one. This one here, there was a ventilation system that basically was cut into the slab just to help try to balance air from one side of the house to the other. However, the mice have found this because there's another way into it, and basically the entire thing was just filled with mouse droppings, filled with mouse nests, just disgusting. Now, should you clean out your vents? Yeah, you should totally clean out your vents, but just think of it this way. All of the air for your house is being pushed through this vent, and before that air comes up into your nose and mouth, it is being aerosolized effectively by all that forced air, and it is catching all of those mouse droppings and all that other stuff, and it's just throwing it into your face. Now, 2 reasons this is bad. One, obviously mice are gross. Obviously, mice poop is gross, but everywhere that mice go, as they go, they just drop little bits of urine. They just little drip, 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 drip everywhere that they go. And that way they know where they've been, where they're going. And it's just a way to like set breadcrumbs so they know how to get back. So not only do you have all that urine coming up, but additionally, hantavirus, not a good thing. Whenever you talk about hantavirus, that is a virus that kills 40% of the people that get it. So if we're still talking about our COVID pandemic, then what we're talking about here is maybe 2% of the people that get it die. Well, we're talking 40%. If you get it, flip a coin, you might die. Heads or tails, you may or may not make it. So whenever we see stuff like this inside of your ventilation system, it shouldn't be that dangerous necessarily because your face isn't right up against the vent register. So the viral load is much lower. However, it's not great. And you definitely want to have a pest control pro come and kill, all the mice, exterminate them, and then also clean up all of their droppings. Now, the cool thing about hantavirus, after 1 week, then everything's good to go. So if you get rid of the mice, wait a week, then everything's fine. Nothing to worry about. So that pretty much wraps up everything. That is this particular in-service training. I think that it was a pretty good one overall. If you have any questions, if you'd like to schedule a home inspection, please visit 2 Moose Home Inspections. If you'd like to check out any of our other blog posts, if you'd like to check out any of our other in-service trainings, we have all that available on our website, 2moosehomeinspections.com. We also have that available on our YouTube channel. Thank you for watching and have a great day.